share my slides. I hope my screen is visible. Uh,
Your screen is visible.
Visible. Okay, okay. Yeah. So once again, thank you for inviting me to take this session. The topic that I'm going to take you, it's a very fundamental session about intelligent system and some idea about neural network. That's what I'm planning to take. So I think there is a one session of machine learning which was already over in the previous days. So then your coordinators has informed that it is better to focus on that neural network rather than go into the fundamentals of machine learning. Hence, I has prepared this slide accordingly. So I hope we are just starting we are just starting that idea of a neural network. I hope all of you are well known about these terminologies. Maybe during your the first lectures about machine learning, fundamentals of machine learning, maybe some of the terminologies are already heard it, right? For example, whenever we are telling about the neuron, it's kind of right. You already know about that. It's a fundamental architecture of a neural network. Then you might be known about the hidden layer. Hidden layer is the layer which interconnecting between the input layer and output layer. The bias is a it's a kind of extra energy we are given to the network so that this output can be coming to our desired level. The activation function is a function which map the input signal into an output level. Maybe this terminologies are somewhat more correlated with the neural network. The remaining terminologies are I think you might be known about that. The training, validation, and testing. So whenever we are coming to a machine learning, the term machine learning, all of you have must understand what is the training, what is validation, and what is testing. So I can just ask you, maybe explain what is that. The training, what is training? The training data, I can tell you the training data. Training data is the data set which is used to find out the parameters of the model. I'm just generally telling that the network or model, which is indicating the machine learning. Okay. So please understand the machine learning means it's actually a approximation of data. There are different kinds of that. It's a fitting of data. Okay. Fitting of data is machine learning. One of the technique of machine learning, it is called the neural network. Okay. So these are the training, validation, and testing indicate. Training indicate the data which is used for finding the parameters of the machine learning model. Might be a neural network model, or might be a support vector machine, or might be any other machine learning kind models. Okay, so then you might have heard about the validation. What is validation? Validation, as far as the machine learning is concerned, the machine learning models are concerned, there have some kind of hyper parameters. For example, in especially for neural network is concerned, the hyper parameters are number of neurons on the hidden layer. Yeah, and if we are applying the regularization parameter is a kind of hyper parameter. So in order to train or tune the hyper parameter properly, then we can utilize validation data. So it is not compulsory to do the validation all the time. Okay. So even though if we properly validated a network model, then we can expect a better accuracy, or the accuracy we are telling in a more generalized way. It is called generalization. So please note down, if you are not aware about this terminology, you can just note down it and later you can study what is that. The generalization. Generalization means, for example, if I'm telling this network is more generalizable than another network. So what do you mean by the generalization? The term generalization, which indicating that, which is especially a special property of a machine learning model, which may not be there in any other kind of mathematical model. So what we are doing, we have a training data. So with the help of training data, we are training the neural network or any machine learning model. So what we'll get a uh, the the parameters, weight or bias according to the related to the network. Okay, so we got a certain number of parameters. Now for testing, we can take a data which is not related to the training data. Okay, in order to test the accuracy of a network model, you can take a data which is not at all, no, there may be some kind of statistical relation, but it's not belongs to the training data. That kind of data is called testing data, and the accuracy which is produced by testing the network is called generalization. Okay, so the accuracy generally accuracy I can tell you in terms of training data, or in terms of validation data, or in terms of testing data. So accuracy which is produced or which is obtained by uh, giving the testing data, it is termed as generalization. That means it should be generalized with a new environment. That is the meaning of that. The another important terminology you have to keep in your mind, which is called regression and classification. So that might be, this is another terminology, regression. So whenever we are designing a machine learning model, these are the two important operation you might have to you have to do it. So regression, what do you mean by the regression? Regression indicating fitting a approximate a curve or a data. Exactly fitting the data or fitting a curve is called regression. And classification mean is kind of classifying whether it is belongs to that the particular class or not. I can give you a simple example. For example, we generally telling uh, one of the prediction, right? For example, I can say weather forecasting. Weather forecasting. In case of a weather forecasting, what we are doing, we will be predicting the tomorrow temperature, right? By today, right? Tomorrow temperature at 3 p.m. What will be the temperature tomorrow at 3 p.m.? It will tell you, if you Google search it that a question, it will tell you tomorrow temperature is like 30 degree, 32 degree. That exact value will be provided. Okay, so that is called regression. That means fitting to the exact value. And the classification means, classification is also, I can tell you about weather forecasting, weather prediction. I can say that you can search in Google, is there any uh, rain is available tomorrow? It will tell you yes or no, right? Yes or no. Answer is yes or no. So that kind of, it will classify whether there is a chance of rain or there is no chance of rain. So this kind of grouping is called classification rather than telling exact number. So for example, if Google is telling that there is a uh, uh, rain for 5 mm, some exact numbers are providing, then it will it will categorize as regression. If it is categorizing into two different or three or four different area, then it is belongs to the classification. Then another terminology you might have been heard about is target. What do you mean by target? The target is indicating the output of output data, which is we are going to train the network model. And the next terminology is features bar attributes. Features. I may give you an example about features in the coming lecture, the coming slides. Okay. The learning means what is that? It's a process of learning the network using the training data, validation data. Okay. Process of finding the parameters of the network using training data or validation data. The backpropagation is one of the algorithm which is used for tuning or training the neural network. decision boundary and linearly separable that we are going to discuss later. So once again, just uh, assuming that these are the known portions which for you. Maybe you have one course in your curriculum. I think there is a subject soft computing, right? It is starting with this neural network, all those things. Maybe let us. I'm expecting that at least the first 5 or 6 terminologies are already known to you, and then based on that we can come to a what is a simple neural network and what is the issue if I'm using a simple neural network, then how we can improve the accuracy of a neural network. These are the today overview. Like, and also if we have a sufficient time, I can show you how we can perform a neural network regression and a classification using the help of MATLAB. So let me come to very simple portion of a neural network, which is called perceptron. The perceptron model, this is the architecture. This is already, I hope most of you are familiar with this architecture. So it consists of a m number of inputs. Let us consider there are m numbers of inputs are there, and there is a one output y of k. So input is transferred to a summing area. It is through a kind of weight which is called a synaptic weight. Then it is summed together, and there will be a bias also given. There is a function. So you might have a confusion how this architecture is coming, right? Generally, whenever any network or circuits is given, there have some kind of proof behind it. Why the circuit is like that? Why the capacitor is coming here, why the inductor is coming here, right? So there we will think it, and we'll find out some theorem associated with that, then, and accordingly we'll put a proof on that, right? Why the capacitor, why inductor? Is there any reason behind about this architecture? That is a one confusion, right? You people will come that. So please understand, there is no proof behind architecture. It is just inspired from the idea of simple human brain. There is no further mathematical logic behind, right? There may be some simple logic might be there, but there is no proof behind it. We multiply weight and then do it. The reason behind this architecture is that it is just inspired from the architecture of a fundamental neurons. I think all of you are aware about the fundamental neuron. I'm not going to give you how this kind of architecture is obtained from the fundamental human neuron. So this is the first invented neural network, okay, which is called a perceptron. And I can just give you a very simple example how we can design a simple perceptron for a problem. Let us consider, you can just see this data set. So how many data sets are there? There are 8 data sets. So 1, 2, 3, 4, 5, there are 8 data sets. I'm dividing the first 6 data sets belongs to the training data. The 7th and 8th data, first 6 data set belongs to the training data. 7th and 8th data set belongs to the testing data. Okay, that means I am choosing the first 6 data set for the training, and remaining 2 data set for checking the generalization capability. Okay, so the data set consists of 2 features. So features means the number of input x1 and x2 are the 2 features. Okay, and output y is the class, another output features. Okay, now this is a kind of classification data. Why it is called a classification data? You can see the output. Output as actually is coming 0 or 1. That means it is telling that whether it belongs to that class or not. Okay, so this is a generalized data for a diabetes patient. Okay, the x1 indicate I think x1 is indicate person height, x2 is indicate person's weight. And then you have a confusion why the 0.7, 0.8, all those things. I think it is normalized into the range of 0 to 1.5. Okay, so this is the x1 is the person height which is normalized into the range of 1.5. And X2 is also person weight, which is normalized into the range of 1.5. And that's 0 and 1 indicate, for example, the first data set you can see the person height is 0.7, second person weight is 0.7, 0 indicate person does not have any diabetes. And the second data you can see the person height is 0.8, person weight is 0.9, that person have a diabetes. So this is a clinical data. Okay, so a person we will get this data from the hospital. Now our objective is to make an automated model or a neural network model, which whenever we are giving a person height and weight, it will tell you that person have a diabetes problem or not. So now the first thing you have to check whenever any data set or any problem it is given to you, first thing you have to see that you have to do is that you should have to plot the graph of the data set. Here the plotting is very easy. Why? Here the number of features are 2, so the dimension will be you can draw the graph in 2 dimension. So here this is a plot of the graph, the data set, where x-axis is x1, y-axis is x2, and you can see it can the x-axis have a 3 zeros. Sorry, the training data consists of 3 zeros and 3 1, which is indicated by the 1 is indicated by a red color, a round with a red color, and 0 indicated by white color round. Okay, this one. So you can by looking this data set, you can clearly draw a straight line between these two data, right? You can see this blue line indicate the straight line of these two data sets. So what is the inference from that? The inference is that this data set is linearly separable. That's why I came to a terminology, decision boundary and linearly separable. So the decision boundary or linearly separable means if we can possible to draw a linear hyperplane, that may be a 3 dimension or 2 dimension or 1 dimension or any other dimension depending upon the number of features. Okay, so if we can possible to plot or draw or we can plot a linear hyperplane between two classes, then such type of data set is called linearly separable data. So I can assure that this is a linearly separable data. And this line is called, or this plane or this surface is called decision surface. Okay. So once we confirmed that this data set is actually linearly separable, then you can try to obtain the equation of the surface. So this is a very simple surface. You can see this is intercept is coming at approximately 1.5, y-intercept also approximately 1.5. Then I can make a generalized equation of the decision boundary, x1 plus x2 minus 1.5 equal to 0. So equation is this one. Now I can write that 1 that is a one array into x1 x2 minus 1.5 is equal to 0. This is in the general form of W transpose x plus b equal to 0, where W is called weight of the neural network and B is called bias of the neural network. So while comparing with this generalized equation with this one, I can confirm that the weight of the neural network I have achieved as 1, bias is minus 1.5. Okay, so this is a neural network architecture. Very easy thing. What is that? You x1, x2, 1 I have chosen. Which why? Because W1 and W2 are 1, and bias I have keep as minus 1.5. Bias is also called another kind of threshold. In this diagram, it is indicated with a threshold. Here I indicated with a input with a it's actually kind of considered as a weight with a input of 1. So this is all anyway, you might be known about that. Bias is another a kind of threshold. So this is very easy. Now what can do the training is over. why it is training is over? We have properly calculated weight and bias. That is the parameters of the neural network. Now, if we can come to the training is completed. The training portion is completed. We can take the testing data. What is the testing data? 7th and 8th are the testing data. You can give the testing data and check whether you are getting the proper output or not. You can check whether network is properly generalized or not. So what you can do, you can just give the our training value 0.9 and 0.5 in this equation here itself, or in this network itself. So 0.9, this is 0.5. So 0.9 plus 0.5 minus 1.5. So which is coming less than, right? There is activation function. The activation function we are using as a signum activation function. This activation function is a signum activation function. What is the speciality of signum activation function? When the input is more than, when input is positive value, output will be 1. When input is negative value, output is 0. So here the summing value we are getting as negative, so output will be 0. So I can tell that the 7th one we are getting as actual. The 0 is expected one. We are also output also getting as 0. Now you can give the next input 0.9 and 1.1. This is 0.9. This is 1.1. I can give it, and so 0.9 plus 1.1 minus 1.5, which is positive value. Okay, a positive number. Then after this activation function, so output we are getting as 1. So expected value is also 1. So I can say that this neural network is having a 100% generalization. Okay, so using for this testing data, we are getting a 100% generalization. Or I can say that this neural network have 100% of testing accuracy. So we have completed a very simple neural network design. So this kind of approach is very, you can go if data is linearly separable. Now you will have a doubt. What happened when the data is not linearly separable? For example, one of the example is XOR gate, right? You know about the XOR gate. What is the characteristics of XOR gate? You can see the x-axis is x1, or I can just indicate in1, whatever. The y-axis is in2, and what is the truth table of XOR gate? Whenever the input, right, if inputs are different, for example, 0, this is 1 0, this is 0 1. Both cases I am getting output as 1. Remaining case output is 0. Okay. Is it possible to draw a linear boundary which discriminate the positive and negative classes? Is it possible? Right, we cannot possible. Why? You can see this is a red color that indicating one classes. This is indicating another classes, and this is also indicating positive class. So it is we cannot draw a linear curve which discriminate the positive and negative, like here. Here we have plotted a simple straight line, right, which can discriminate the red color and white color. Okay, here we cannot draw a single straight line which discriminate. Then how we can draw a two decision boundary, right? We can see this graph, this plot itself. I have drawn two line. So in order to consider multiple hidden layer, right? I can say that multiple decision boundary, not hidden layer. In order to consider the multiple decision boundary, what kind of approach we can go? Here you can understand that here on that the system is linearly separable, and we can easily draw a linear curve between the positive classes and negative classes. In such cases, simple neural network with input x and x1 and x2 and bias and one output, that is enough. That is enough to design this kind of neural network. But in this case, we cannot draw a single straight line which discriminate positive and negative class. So what we can do, we can draw two decision boundary which can be discriminate positive and negative classes. So in order to accommodate more hidden, decision boundary, what one approach is that you can incorporate hidden layer in the neural network. So you can see this picture. So what is it consists of two input x1 and x2, and that inputs are connected with the hidden layers. You can see these are the two hidden layers which is connected with an output. So that I can say that this neural network have a one hidden layer. Okay, so the more hidden layers are incorporating, which it get a capability to approximate more complexity network. So let us consider this network. What is this is a decision boundary. The black color and white color indicate two classes. Or this line indicate decision boundary. So I can say that the positive and negative classes I can discriminate with the help of a single straight line. So a single neural network without hidden layer is sufficient to approximate. Now in this case you can see this is a kind of a decision boundary which is not linear. Right. So there is no linear separability in this data. So how I can, is it possible to design a linear network? No, I cannot possible to design a network without hidden layer. So what can I do? What can I do in order to approximate this kind of hidden layer or this kind of architecture? I need to add more hidden layers. This is one hidden layer I added, or more complex hidden layers are there, then I can add more complex networks are there. I can add more complex more hidden layers like this. You can see here two hidden layers are added. So in order to understand the importance of the hidden layer, there is TensorFlow is already implemented one idea which will tell you the importance of the hidden layer addition. So I can go to that website. TensorFlow is already implemented one website regarding the, maybe 1 minute. I'll share my screen once again. I hope that the website is visible. My Google Chrome screen is visible to you. Hello, whether my the screen is visible right now?
Yes, sir.
Okay. So please, I hope it is. This is a one TensorFlow easy to they have, the people are implemented a simple architectures for neural network where it will give a lot of versatility to increase the hidden layer or decrease the hidden layer or change the data set. So anyway, please understand there are 4 data sets are given here. So that this is the first data set, which is, you can see the graph that yellow color and blue color are the two classes. Okay. So in this data set, yellow color and blue color are separated by a non-linear decision boundary, right? What is a decision boundary? Decision boundary is actually a circle. Now I can come to the another data set. Here, this is another data set. You can see it more complicated hidden layers are there. And what is this case? This is a linear curve, right? You can clearly draw a decision boundary between a linear decision boundary between the positive class or yellow class and green class. You can see this is a much more complex more complex network, or I can say that the decision boundary is kind of spiral, which is so complex. So what I told you, this in this case, I'm initially starting with a very simple, you can see very simple data set, which is a linearly separable data. So what is the specialty I told you? For linearly separable data, we does not require any hidden layer, right? So I have removing all the hidden layers. So now you can see, the only two input x1 and x2 are the input, no hidden layer. I can train the neural network. This is a train option. Okay, well, just click it. So it's whenever I'm clicking here, the neural network start learning. So learning is happening continuously. You can see the epochs are increasing and the learning rate. These are the parameters of the neural network. And this guy, you can see the decision boundary after training, or training is continuously going on. Anyway, after certain iteration, the network is reached the a fixed decision boundary. Okay, so you can see that this is a decision boundary, and it is possible to discriminate. That is our design. This neural network is possible to discriminate the positive classes and negative classes very easily without help of any kind of hidden layer. Okay, so I hope it is clear. Now we can take next data set. What is this data set? This data set is actually the hidden layer is kind of not hidden layer. The positive classes and negative classes are in a different shape in such a way that the decision boundaries become as like a circle. So I can just run my code. I have added uh, no hidden layer. You can see there is no hidden layer here. I just try to run whether my decision boundary is possible, whether I can approximate this kind of network with the help of a neural network without hidden layer. Are you getting any kind of hidden that decision boundary here? No, right. We are not getting any possible decision boundary here. So then what do you understand? What we understand? We are not possible to design a neural network without any hidden layer for a non-linear separable problem. Now I can try to add a one hidden layer. So one hidden layer is added with the two neurons on the hidden layer. I can add one or two, three neurons are added. Okay, three neurons with one hidden layer is added now. Now I can start training the network. This is a training option. I just clicking it. You can see, yeah, why the epochs is increasing. This you can see a clear decision boundary is happening. You can see this three decision boundary is happening between the positive classes and negative classes. Why the decision boundaries look like kind of okay, right? Could you tell me what is the shape of the decision boundary? It's approximately a triangle, right? Why does it look like a triangle? Because I have you can see the decision boundary which is of the hidden layer. This is a decision boundary of the hidden layer, which is single straight line. When I am coming to the second one, this is the hidden layer, the decision boundary of second hidden neuron. This is a decision boundary of third hidden neuron. Whenever we are adding these three decision boundary, then it will come like a triangle structure. If I add one more hidden layer, then you can see I added one more hidden neurons. Hidden neuron I added. Then you may get a somewhat other shape, right? Maybe it is now deviating from the triangle shape. It may be going to other kind of shapes. Even though if you are adding more hidden neurons, then you can see what is the shape is getting. Yeah, it's almost coming with a shape of like a circle, right? Still is not a proper circle. So you can see what is a decision boundary provided by each hidden layer. This is a decision boundary provided by first hidden layer, second hidden layer, third hidden neuron. I'm sorry, not hidden layer, it is hidden neuron. Third hidden neuron, fourth neuron, fifth and sixth. All the finally the final output will be a combined action of all the hidden neurons. You'll get a shape like this. Now I can take the next data. This data set also I am going to run. You can see what kind of hidden the architecture you are getting. You can see it's almost you are getting approximated result. It is this hidden layer, one hidden layer with six neurons is enough to discriminate the positive classes and negative classes easily. Okay. So here also we are getting some satisfactory result. So whenever we can come to the more complicated data. This is a complicated data. Why it is called complicated data? The decision boundary is kind of complicated, which discriminate the positive classes and negative classes. I can run this architecture. You can see in this case, are we getting any proper decision boundary or expected decision boundary? Right. So that means this neural network, this hidden layer is not sufficient to approximate this complicated data. So what is the procedure? You can add one more hidden layer. So I added one more hidden layer with much more hidden neurons. Okay, 4 hidden neurons are added. Then I can train the network. Are we getting any kind of spiral architecture? Still, yeah, sometimes it is converging, but still is we are not getting our expected decision boundary. Then what is the next procedure? Can try to add one more hidden neurons, one more hidden layers with the more hidden neurons. Then you can try. So please understand that there is no hard and fast rule to increase the number of hidden neurons or to increase the number of hidden layers. Okay. Maybe some people are applying the validation technique to find out the optimal number of hidden neuron, all those things. Still, there is no hard and fast written rules to how to find out a hidden neuron or how to find out a proper hidden layer. There is no rules based on the complexity of data and based on the trial and error as like I have done. You can design the number of neural network. Yeah, now you can see almost some kind of architecture we are getting, okay, which is better than the previous case. Okay. So now you anyway you are aware about the neural network and the architecture we already studied, and also we understood that more hidden layer is required in order to accommodate more complex network or in order to accommodate more complex data set. Okay, and now in a net if a network more with a more hidden layers are there, such kind of network for such kind of learning is called deep learning. You might be known about that. Now, how we can do this neural network in MATLAB? That is the next agenda of my talk. So that's very easy. As far as the MATLAB is concerned, it's one of the easiest toolbox, easiest language where we can do all our analysis. So there are three command you have to keep in your mind: new ff, train, and sim. Maybe I can show this command and graph while sharing my MATLAB window. So is it my MATLAB window is visible?
Yes, sir.
Yeah. But what about the code? It can be readable, right? Code provided by in the MATLAB is readable, right? Okay. Hmm. So you can see this is a very simple code. I can share this one. No need to write. No need to copy all this code. I'll share with the your coordinators. So this is a very easy, one of the easiest the function approximation implementation in MATLAB. The function that we are going to approximate is sinc function. I think all of you are familiar with the sinc function. I'm going to run this sinc function. One minute, is still, yeah. This is whether the graph is visible right now. The sinc function in the MATLAB window is visible. Hello. Whether my MATLAB window with this graph is visible to you right now?
No.
Okay. One minute. Then I'll share my screen completely. What about right now?
Yes, sir.
Yes.
Okay. So what I have done, I have my objective is to approximate a sinc function using neural network. Okay. So this is the sinc function graph. Okay, sinc means sin x by x. All of you are aware about the sin x by x, right? It is have a very good application in signal processing, all those things. So this is a best example for a nonlinear architecture. Okay, a nonlinear curve. You can see this is a function, and we are taking x value from -10 to 10. So this shape is there. Now my objective is to approximate this nonlinear function, the sinc function, using neural network. So what is the first procedure I told you? You had to take the procedure of any neural network training is that what you can do, collect the sufficient data set. So while collecting the data set, you please keep in your mind that the data set should be excite with all our working area. Okay, that means I can give an example. In this case, my objective is to approximate the sinc function in the range of -10 to 10. Then can I choose a training data which is coming only in the range of from -10 to -2? I'm just choosing the training data only in this range. Is it possible? It can possible, but the neural network will not behave apart without apart from the region -2. Okay, so what I can do, your selected data, our selected training data should be belongs to our complete minimum to maximum range. That means I should have to choose a training data should be in between the -10 to +10. Okay. Now what is the next procedure? You have to do a proper validation. So there should be a validation data, and then you have to choose a testing data set also in order to find out the generalization capability of neural network. So these three data set you have to divide the overall data set. You have to divide it into training data, validation data, and the testing data. So how we can divide it? This is a data. This is a data I have took. So x is the input. That is x is the x-axis value. Y is output. There are only one input I have chosen. That is x. That is a data set vary from -10 to 10. Y is sin x by x. Now I'm choosing the training data and testing data separately. So how I can do it, you can see the training, I'm choosing alternate data for the training and remaining alternative data for the testing. Okay, that is training data. I can choose 1 to 2 end. 1 to 2 end means a data starting from the first, then the third one, then fifth one. That is all the old data. All the old data I'm choosing for the training, and all the even data I'm choosing for the testing. Okay, now I have divided the training input, training output, testing input, and testing output. The command is very easy. This is the command for the neural net training the neural network. What is the command? New FF. New FF. Then you have to give the training input, training output, and the number of hidden neurons. You can see the 10 indicate number of hidden neurons in the hidden layer. Okay, number of hidden neurons on the hidden layer. So I can just show you the neural. Currently, I'm going to run this app. So I'm going to run this code. We'll see what is going to be happen. Yeah, this is the initial sync function. This is my network. Okay, what? How many hidden neurons I selected? One hidden layer with 10 hidden neurons. Okay, that's why you can see the architecture. The input is 1, input is 1, output is 1, and hidden layer is 10. Now I can start training. This is the command for training. What is the command? Train. You can use the command train for training the neural network. I'm just running the code. Then what happened? There is a pop-up window will be generated. This is a window which is for, which help for the training. These are the training parameters. Then it will tell you the number of epochs, time for the training, and performance, gradient, validation, all those things. Also, you can see the performance by clicking the performance graph. Yeah, you can see this is the overall what the command train default command. What happened? It automatically divide the training data, overall data into training data, validation data, and testing data. So this is the graph of that based on the factor that based on the ratio 7 is to 3 is to, I think 7 is to 1.5 is to 1.5. That is 70% of the data for the training, 15% is for the validation, 15% for the testing. That is, you can change that idea also while doing the different command here. Okay, you can change the training testing ratio. Default the ratio is 70, 15, 15. Now we can see the curve here, and it is always performing the validation. And at the iteration of almost 370, I'm not, yeah, I think 370, we are obtaining a minimum validation error. So the network will be stopping at 370 iteration. So the network training is over, and even you can see the curve fitting, whether network is properly fitting with the actual data. The 100% fitting is happening with a regularization value of 1. The R is equal to 1 means perfectly fitting. Okay, now the training is also over. Now I can test it. What is the command for testing in MATLAB? Sim. Sim is the command for testing the network. So I can run that simulation. Sorry, that command sim for my test data. So you can see the accuracy, how much accuracy I'm getting. I'm getting a training error, training root mean square error as 7.8 in 10 raised to minus 5, and testing root mean square error is this value. So I can say that the value that I have obtained is very small. Okay, so then so I can say, and also I can draw the graph. I can plot the network output. This is a plotting. Yeah, you can see this graph. What you are obtaining. The blue curve indicating actual data. Red color indicating the neural network output. All right, and almost perfectly fitting. Right, I can say that 100% fitting with a very small error range. What is error range? In the range of 10 raised to minus 5. So that means if we have a complex nonlinear data, if you want to fit with using neural network, you can go for this method. And if your network is more, your training data is more complex, assuming that the hidden layer 10 is not sufficient to approximate the network, what can do? You can add the one more hidden layer. I can add one more hidden layer with the hidden neurons as 5. Okay, so you can see the network now. Yeah, this is a network. There are 2 hidden layer with 10 neurons on the first hidden layer and 5 neurons on the second hidden layer. So this that means different options are there to change the hidden layer, hidden neurons, and everything in the command new ff, and accordingly with the help of trial and error method, you can choose a proper hidden layer and hidden neuron so that we'll get a satisfactory accuracy. Now this can be applied for a just 1 minute. I'll share one more. Okay, this is the 3 command I'm telling. New ff, train, sim. Okay, new ff. What is the arguments of the new ff? Input. You can see input, that is input data, target data, hidden layer. This is a command. Train indicate train NN mean neural network, input comma target sim. This is a overall equation, and this is example I am telling sin x by x. Okay, the graph. This is a data division, then neural network finally. So even another example, I'll share this code if you want. This is all our regression data. I can choose another important area is called classification. So here we are going to do a data set classification. So I can choose a very simple uh, data set which is available in the MATLAB or which is available in the online. The data set is called Fisher Iris data. I think those who are working on the classification, they are familiar with the Fisher Iris. The Fisher Iris data, it's a kind of flower, okay, flower which have a three different classes. So what are the classes? The first class of flower is called Setosa. Setosa. The second class of flower is called versicolor. Third one is called virginica. Okay. So there are, let us consider three classes are there. So my objective is to classify the flower into whether it's a Setosa or versicolor or virginica. So our data set consists of four features. So what are the features we are selecting? The features are sepal length of the flower, sepal width, petal length, and petal width. Okay, so these are the four features. Total number of data are 150 and three classes. Don't confuse with all terminology. So how many features are there or how many data are there? There are four features. Okay, four features. 150 data are the total number will be 150, and out of that 30 classes, three classes are there. The first 150 data are belongs to the class 1, or I can say that Setosa. The second 150, the second 50, 51 to 100 class is the images are belongs to the class 2, and the third 50 data are belongs to class 3. Okay, if you are in your MATLAB, if you type load Fisher Iris, then you will get this data MEES, this containing, you can see what is the size of that data, 150 into 4. So why it is 150 into 4? The 150 indicate number of data sets. 150 samples are there. 4 indicate features. 150 that what are the features? Sepal length, sepal width, petal length, and petal width. 4 features are there. Species indicate the classes. Okay. So now I can train the network. Okay, what is the command? Very easy. In order for the classification, NeoFF train sim. Then in order to draw the confusion metric, you might be aware about the confusion metrics of the classifier, right? So in order to draw the confusion metrics, you can just use a command plot confusion. Okay, I can just show you that classification example in the MATLAB. One minute. Okay, this is a yeah, I can just write load Fisher Iris here. Yeah, here I'm going to write my command load. I just I'm clearing my window, clear all. So all the window will be clear. Now I can load my data set. Load Fisher Iris. You can see the data set. I am just double clicking on the data set. You can see this is a data. There are four features are there. This is a sepal length in centimeter, petal length in centimeter, or the petal width and sepal width. Four features are there. Out of the features, the first 150, yeah, you can see up to this data set, 149th data set belongs to or up to 50th data set are belongs to the class 1. Then from 51 to 100, it belongs to, up to this data, it is belongs to class 2. From 101 to 150, yeah, up to 1, this belongs to class 3. This is the overall class. Now what can do, I have to take the code. I need to finalize the training output. Then I can train the net. This is very easy. Train the simple training mechanisms are there. Yeah, okay. So we can run it. What is the we can the simple code is we can copy paste this code. This is a very easiest code. So we have created the train output. 1 minute. Even we can create the training output very easily. How we can create it? What I'm telling? The train out the output data. Train output data. First 150 the 50 data belongs to the class 1. So I can write once, right? 1 into once of 50 data. This is belongs to the class 1. Then next to 50 data, once of 50 comma 2 belongs to the second class. Then next to 50 data, once of 50 comma 1. Sorry, this is 50 comma 1. So we created the training output. Train output, you can see, I'm just showing it. You can see. Hello, am I audible now?
Shihab. Shihab, Dr.
Hello.
Shihab, myself,
Hello.
Dr. Shiba. Is it over? Session is over?
Hello, am I audible? Hello.
Audible, audible.
There was a network. Okay. There is a network problem here. Now it is solved. No issue.
Okay.
Shall
are you-
continue. I will take only 5 to 10 minutes.
Okay, thank you. Thank you, Shihab. Thank you. Okay, audible. It's audible. Thank you.
Okay. I hope my screen is visible.
No, it's not visible. It's not visible. Shihab, screen is not visible.
Yes.
Hello. Still am. Hello. Am I?
Audible, Shihab, it's audible, but screen is not visible.
Yeah. The problem is that yeah, I'll share once again.
Okay, okay, thank you. Okay, now it's visible. It's
Okay.
visible.
Okay. So once again, I'll just come with the topic. What we were discussing about the classification using neural network. So one example I have chosen. The example is Fisher Iris data. Okay, the Fisher Iris data consists of a 4 features with 150 data and 3 classes. The Setosa, Versicolor, Virginica. So you can download this data set from the MATLAB itself by using the command load Fisher Iris. The data set are available. The data set is available in the workspace with the name MEES. Okay, so this is the data sets. The first 150 data sets are belongs to the class 1. Second 150 data, first 50 data belongs to the class 1. Second 50 data belongs to class 2. Third 50 data set belongs to the class 3. So now I need to create a proper the proper training output, or I can training output also created. This is the I am giving one as a that in number 1 for the class 1, and that is happening up to 150, and the number 2 for the class 2, and number 3 for the class 3. Okay. Now you have to choose a proper then there is out. Now what you can do, we have selected the output, then very easy, 3 codes are there. What is the code in order to run that? This is the code. Train, new FF, train and sim. Just copy and pasting here. The MEES target is actually train output. First I run with the first code, train, new FF. Then this is train output. The new FF is over. Next code is train. So the training is also completed. There are 4. You can see 4 input with 10 hidden neuron, 1 hidden layer with 1 output, which will tell you what kind of class. Then you have to find out the sim. So this is my sim. I'm testing with all data MEES. The output will be that. Now I can round the data by using command, because we are doing classification. So you have to get a the round is so. Now you can see the output what you are getting. You can see the output. I can show you y is equal to y cap. You can see this is output after training the network. Almost 50 data, 50 output I'm getting 1, right? 50 output I'm getting 1, as like in the training, as like in the data sets. Then from 51 onwards, I'm getting output as, yeah, up to 100, I'm getting output as 2. Then from 101 to 150, I'm getting output as 3. That means I'm getting 100% accuracy. Okay, so the classification also is completed. Now there is option to draw the confusion matrix also using the command plot confusion that you can do. You can apply the plot confusion in order to draw the confusion matrix of it. So here we are concluding that. Just I'll come to my PPT back. So what we have studied till now, there is a new, we can design a neural network for two ways. What is the first option? The regression. Regression means function approximation. One example also we have shown to you. And the second example, the second option is classification. We can classify the data set into different classes using neural network. Okay. And I also we understand that while adding the number of hidden neurons, it can learn or it can study the more complex patterns of the data sets. Now, how we will do the optimization, right? Like what do you mean by the learning of a network? The learning means finding the proper weight associated with the network is called learning. There are different optimization algorithms are there. I'm not coming to the all the ideas. My objective is just to familiarize the neural network along with the some toolbox. Okay. So anyway, all of you are familiar with that, the gradient descent algorithm, right? The gradient descent algorithm, fundamental equation of the gradient descent algorithm. Then if more hidden neurons are added, then it is called feed forward neural network. The back propagation is one of the algorithm to train the network, right? And we know that back propagation algorithm, everything is already available. So I just come with an idea, just give you a small hint. What is the problem of a conventional, what is the problem of conventional neural network and how it can be compensated? Okay. So the problem is that I told you the conventional neural network we are using, what is algorithm we are using for conventional neural network? Back propagation. And back propagation is actually based on the gradient descent algorithm. So the main problem of a back propagation or gradient descent algorithm is called, it's a local minima problem. You can see this is an example of this is an error curve associated with the one example. Okay. You can see this error curve have multiple minimas, right? This is a one minima. This is another minima. This is another minima. You can see that this only one global minima, remaining are local minima. Since we are optimizing, we are training the network based on the gradient descent algorithm, there is a chance that this network can trap into this local minima rather than the global minima, which is depending upon the selection of the input parameters, right? The selection of the initial parameter. For example, if I have chosen an initial parameter here, so the training will come here and finally it will come here, it will reach this local minima. What happened? It will be trapped into that minimum area rather than reaching to the global area. So that is a main issue of whenever we are coming with a back propagation. Okay. The another problem is called a gradient vanishing problem. This is one of the main issue, especially for a deep neural network. Gradient vanishing problem means the back propagation algorithm you are already known, right? The back propagation algorithm means propagating the output error back to the each layers so that weight can be updated based on the error of the output layer. So while we propagating error back continuously, for example, especially deep neural network, assuming that there are 100 hidden neurons, what is the issue? Every time the error will be propagated, then updated is coming back to back. So once in certain cases, somewhere the error becomes zero. What happened? There is no further updates, right? There is no further improvements of the weights. So that is called the gradient vanishing problem. If the error, that back propagation, if we are doing continuously, sometime if gradient of the system may vanishes or may come converges to zero, such cases, the sum of the neurons are not updated because of the gradient vanishing problem, which will create some issues. Another problem is that iterative learning technique. It's an iterative learning technique, right? It will take longer time since, right? How much iteration we have done in the previous training? We took almost 500 or 300 iteration in order to converge into a final answer, right? So it's actually if a big network is taken or big data set is there, the training of such a neural network with such big data set will be take more time. Okay, so the convergence of the global value or local value also generally slow because we are using gradient descent algorithm. So there are, so please understand there are a lot of issues are there associated with the back propagation when we are using a gradient descent algorithm. So I just giving a small research idea, right? So Professor J.B. Hong is a professor from NTU Singapore. He has invented very simple one advanced network which is called extreme learning machine. So those who are interested about machine learning or advanced version of the neural network, you can go for this idea. You just search it his profile. Uh, Professor J.B. Hong still is working as a professor in NTU Singapore. Okay, so it is called extreme learning machine. I'm not going to the theory of extreme learning machine. So just giving some hint about the research. So the advantage of that extreme learning machine is that the conventional backpropagation, I told you, what is the main issue? The local minima trapping, right? Another problem is slow convergence and number of iteration, all the things. So while applying the concept of extreme learning machine, you can see that this is extremely faster than the backpropagation neural network. That is the extreme learning machine. They are telling that in their paper, in extreme learning machine paper, they are telling that the extreme learning machine is 1,000 times faster than a neural network. You can understand how much 1,000 times. For example, if backpropagation is taking 1,000 seconds, this will take the same problem if you are using extreme learning machine. It will take only 1 second to train the network, and also greater generalization, greater accuracy when we are coming to that. So those who are interested, these are some mathematics associated with that you can understand what this is a comparison between the backpropagation and extreme learning machine. The problem I told you, what is the main issue? Of backpropagation, it may converges to local minima. But whenever you are using extreme learning machine, it have a unique minimum solution always. And another advantage is that the backpropagation algorithm, the optimization we are performing by minimizing the error, right? Here we are performing the minimization error along with the minimizing the norm of weights. So whenever we are minimizing the norm of weight by using the gradient, you might be aware about that idea. Whenever we are minimizing the norm of weight, in such cases, we can expect a better generalization. And also it is an iterative procedure. I told you, right? Gradient descent algorithm is an iterative procedure. It requires some kind of stopping criteria. And what is the advantage of ELM? Please understand, ELM we are performing by assuming that network is linear. That means there is no iterative procedure. That is, we are not required any kind of iterative procedure. It will converges within a single iteration. Within a single step, it will converges. That is a very good advantageous thing. So that's why we are the people are telling that the extreme learning machine is 1,000 times faster than the conventional backpropagation neural network. So these are the simple applications. There are a lot of applications are there. So if you are interested, you can download the code also. This is here, the code will be available. Just search it, Professor J.B. Hong, NTU Singapore. It will be directed into his website, and he has also given the MATLAB code, Python code, everything associated with that. You can download it accordingly, and you can enjoy. You can give your own data set, enjoy the training time. You can see this is the one data set I have given. Okay, the training time it is showing 0. 0 means it's very nearer to that point, maybe 0.000 something. Okay, so training time and showing it's 0. That means that much faster to get a result. So even this is a Professor J.B. Hong website. You can download the MATLAB code if you want, Python code if you want, and he has applied for different applications also. And he there later after 2015 or 16, people are also implemented a compared with the conventional. What is conventional deep learning? So we know we are most of you are aware about deep learning, right? Deep belief network, deep Boltzmann machine, or stacked auto encoder. All the ideas are already you might be heard, and they have compared with a deeper version of ELM. They are added more hidden layer. So they are telling that hierarchical deeper ELM. They are compared with this deeper ELM with other existing deep belief network and Boltzmann machine. You can see that they got almost better testing accuracy and maybe a comparable accuracy, right? comparable, but the main important factor is screening time. You can see Boltzmann machine, they took almost 19 hours. Deep Boltzmann machine, they took almost 19 hours for this specific data set. Okay, but they took, if we are going to ELM, that extreme learning machine, they took only 281 seconds. So that much faster, and they are also applied for object detection. And that means they are replacing that convolution neural network or any other deep neural network with the extreme learning machine because of the faster training operation. Those who are interested on the research, you can come with that incremental ELM, hierarchical ELM, local sparse ELM. Sparse ELMs are some recently, not recently, they are published in the 2015 or 2014, like that. And that's all about the my lecture. This is the final. If you want to, if you are beginner of machine learning, first confusion coming in your mind is that where I'll get the data set, right? Where I'll get the data set to test some machine learning. So that is best option is UCI repository is one of the best option. UCI machine learning repository. You can Google search it, UCI machine learning repository. You will get 1,000 or lakh of data sets. Different data set you will get it. You can download a suitable data, right? You can now, and you can do your that generally data set will be in form of a text format or in the form of a doc, or maybe maybe in Excel format also. So that you can download it and you can start your machine learning application on any specific data. Even you can search it if you are interested about the EMG data, ECG data, power system data. You can search it. That data will be available. Mostly the data will be available in the UCI repository. If it is not available, you can also search this kind of Kaggle is another option. Kaggle, you can search it. And different repositories are there. You can search it accordingly if you want. So that's all about my lectures. If you have any doubt about this current talk, you can ask. Because I haven't gone through much area. I just given small introduction of what is neural network.
Shihab,
Yes, yes.
Dr. Shihab, shall you share the material?
Yes, sure. I will share with you this PPT with you all.
Okay, session. Have any doubt? Can ask. Participants, feel free to ask questions if you are having doubts. Shall I move to the last? Shall I move to vote of thanks?
There is one chat. Okay.
Session over?
Yeah, it's over.
Okay. Then, okay. Is there any query, sir, in chat box?
I didn't find any questions in the chat box.
But that's for vote of thanks actually from participants. Thanks, sir, for this very informative and interesting session.
Okay, thank you.
Okay, then Mukhtar, please present a virtual moment with sir. And after that, we can do vote of thanks by Shiba ma'am.
Thank you.
Okay, thank you, sir.
Thank you.
Shiba ma'am.
Okay, we'll continue. Okay. Good evening, all. Today we had an eminent expert, Dr. Shihab, for handling the topic application of AI in engineering theory and practices. His own views and simple explanation of ANN, machine learning methods, MATLAB toolbox about different toolboxes in MATLAB, everything, I need to mention my deepest sense of appreciation. Here I can take this opportunity to thank him for his great support. Also, I extend thanks to all the participants for their cooperation of the smooth conduct of the session. Thank you all.
Thank you.
So thank you, Shihab sir. Today's session is over actually. Tomorrow's session will start exactly at 9:30 a.m. All are requested to join in correct time. So thank you all.
Thank you.